There we go, we're live. Enzo's favorite joke. He's just proud that he gets it now. All right. Number one. So we have a graph. We have 1, 2, 3, 4 sections. How is he moving in part one? So the key, first of all, we have to identify what kind of a graph this is. It's a position versus time graph, because I'm going to give you on your test a position time graph, and I'm going to give you a velocity time graph. You need to make sure you understand which one is which, because the slopes mean different things on those graphs. The heights mean different things on those graphs. The fact is, a position time graph, then I know that the slope is the velocity. This is a positive, unchanging slope. That means he's moving to the right at a constant speed. This is a slope of 0. That means his velocity is 0, standing still. This is a slope, negative slope. I think we would interpret that to the left at a constant speed. And you know what? That's also standing still. In fact, he's come back to where he started from. Yes? Is A, E, B, E? Yeah? Okay, now we got a velocity time graph. So now I got to think, instead of how high I am being how far away I am, and the slope being the velocity, now how high I am is how fast I'm traveling, and the slope, hey, what was the slope of a velocity time graph? It's the acceleration. So this section right here, they didn't ask me about, but had they, I would have said, you're going to the right and you're speeding up. I would have picked, I didn't ask you for section 1, but I would say C if I had done section 1. Section 2, what's the slope? What's the slope? That's not a positive slope. What's the slope? 0. What's my velocity then? Constant. My acceleration is 0. So this is a constant positive velocity. It's positive to the right, constant speed. This is also A. That's why I told you, you have to make sure you figure out what graph is what. By the way, I didn't ask you about this, but this would be slowing down at a constant acceleration. This right here, how high is this line? It's meant to be a trick question. How high is that line? 0 high, that's your velocity. You know what? You've come to a stop. Now you could say, oh, it's horizontal, Mr. Dewick. That's constant velocity. I say, yeah, but a better answer is not only is your velocity constant, it's 0 because you've stopped. So AE. Number 7, for this question, draw the position time and velocity time graphs for the following description. Okay. A student walks at, we're doing position time. So when they're talking about velocity, that's the slope. Walks at a constant velocity. I would be looking, now your graph might be higher or lower, or it might have a different steepness. I'll talk about how we'll mark it afterwards, but I'll be looking for a chunk that looked like that. Suddenly she stops and there is a short pause. I would look for a chunk on your graph that was horizontal, because that's a velocity of 0. Then she runs backwards. Now, I'm going to be fussy here. If she runs backwards, it would look like that, and she's running, so it should be steeper than your first line. Should be steeper than your first line. And then she stops at her locker. Sorry, let's try that again, not being below. Then she stops at her locker. Whoops. Let's go thicker red. I would expect some kind of a short little horizontal chunk there. That's where she's stopping at her locker. This question here is worth 2 marks, and I would say I would give you a half mark if I saw that, a half mark if I saw a horizontal section, a half mark if I saw a heading downhill but steeper than your first section, and a half mark for that. You could be higher, you could be steeper, but it's that shape. Yes? Okay. Now velocity time. Okay, now I got to go velocity time. Velocity time. Walking at a constant velocity, that would be walking at a constant velocity. A horizontal line above 0. Suddenly she stops. That would be that right there. velocity of 0. I'm not sure how long it is, Jordan. I know there's a horizontal chunk, though. There's my short pause. She runs backwards. How would I show backwards, first of all? Where will my line appear? Yeah. Below. And how would I show runs compared to walks? Yeah. I would put it down here somewhere. I would like this distance to be bigger than that distance, to somehow show that that speed is more negative but faster. So the way I'd be marking this, whoop, come back. Go away, there we go. Oh, and then stops at her locker. Geez, let's try that again, Mr. Duke. I'd be looking for those 4 chunks. Now, how do you connect them? Jacob, that I'm not going to be too fussy on. If you did this, I'm okay with that. If you did that, I'm okay with that. If you did that, I'm okay with that. The acceleration portions of this question are a little strange. So if you didn't connect them, if you said, I'm not quite sure how to connect them because I don't know how fast she's changing her speed, I'd be okay with that too. If you connected them kind of slanty, if you went like this and like this and like that, I'd be okay with that too. But what I am saying, to get your 2 marks, you see the 4 horizontal sections there? Half mark for each of those somewhere in your sketch. Is that all right? You can get a lot from a graph. Can you give yourself a nice clear score out of, count them, 10? Make sure your name is on them, and could you pass them inwards, please? So Mr. Dewick was typing this quiz up in a hurry, and he screwed up royally. If you look at quiz 2 here, I forgot to put the exponents after the 10s in the scientific notation. Look at these questions right here, and it's like 3.8 times 10 to the 6.1 times 10 to the So you know what? Here's my low-tech solution. Cross out number 1. Okay? Cross out number 1. Can you make those bonus? No, shut up. Cross out number 1. A recording timer makes 225 dots in 5 seconds. What's its frequency? Oh, we did a little lab on that. I'll let you think about it. A recording timer makes 625 dots in 10 seconds. What's the length of time between each dot? Ooh, that's the period. I'll let you think about that. A car travels 40 kilometers in 30 minutes. What's its average speed in kilometers per hour? So a little average speed question. 30 minutes, I'd probably change that to hours, which is fairly easy to do. Number 5, it took me 30 minutes to get here, traveling at an average speed of 80 kilometers an hour. How far did I have to travel in meters? And then number 6, here's a graph. I've given you the y-intercept. See it clearly, Abraham, on there? I labeled it. Oh, and I gave you 2 points. Are those 2 points enough for you to find the slope and rise over it? Find me the equation, but do me a favor. Please don't use y and x. Use proper variables, as I yelled at you about yesterday. I think I would not use a y. I would use a letter and I don't think I would use an x. I would use a letter because I'm looking at the graph. Okay? Tuck that away. Can you get out the notes from where we left off last day? We started looking at the constant acceleration equations, the big 4. And we got right to example 4. Pause here. I'm going to do a few more examples, and then I have a sheet that's nothing but practicing this. So if you were away last day and you don't have the notes, now is your time to speak up. So let's continue on. We said our approach is DFIC. Now, there's going to come a magic time, Janaya, sometime in the next few weeks, when you'll stop listing the data quite as much, when you'll be so good where you realize you can jump straight in and keep going. And in your homework, if you get that good, knock yourself out. On a test or a quiz, do I take shortcuts? No, I'm a good test or quiz writer. I show extra work on tests and quizzes. But I have no problem if you try and push the boundary, push the envelope a little bit and see how good you can get at this. So let's go. Example 4. A car moving at 30 meters per second to the right slows down, accelerates to the left. At 9.8 meters per second squared, how far does the car go before stopping? What's this question asking me to find? I'm going to write down D equals question mark. Why, Cole? Because it's no longer blank. I feel better. I'm more relaxed. And I think it's just a good strategy. Hey, figure out what they're asking you. Figure out what they're asking you. Ask what they're asking you. All right, let's see if we can list some of this. Sean, my friend, the 30. See the 30? What is that? Hint, look at the units. What is the 30, folks? Yeah, that's the units. What is the 30? Thank you, Captain Obvious. Okay, first of all, it is a velocity. How do you know? Meters per second. Which velocity? And that you have to just read the question carefully and use your more gooder English. Okay? So I'm going to write down VI 30. As I keep reading, I see a 9.8. What's that? Sorry? Acceleration, except we're wrong. It's not 9.8. Why is it negative? What tells me that? 2 words, 2 phrases. To the left or slows down. Either of those. You know what? I better let this acceleration be negative. Now, if you missed that, I'll show you later on where you would have got a weird answer and it would have said, hello, McFly, something's wrong. And you would have probably gone back and said, one of my signs is wrong somewhere. So there is one of the things I like about physics, there are built-in error checks along the way. How many things do I have listed right now? A total of 3. 1 I don't know, 2 I do know. Cole, you can't solve anything with 3 things. You can't use 2 to find the 3rd. In physics, in this unit, you're always going to need 3 pieces of information to find the 4th. What that means is there's something else hidden in there. What? I heard someone say stopping. That's the key word. Jamie, what? VF is 0. So, keywords you want to start to look for, Kelly. At rest, or comes to rest, or stops. Stops is the easiest one. At rest, though, is the physicsy term. How many things do I have listed now? I know 3. I've listed 4. I'm good to go. I'm looking for an equation from those 4 that has D, V, I, A, and F in it. Which one? VF squared. I agree. I agree. And what I'm encouraging you to try and do is to see if you can get to the point where you can rewrite these in your head and get the D by itself. Let's see if we can. Let's see. First of all, I'm going to drop the equal sign down. Okay. How would I get the D by itself? Well, I notice there's a 2A. What's the 2A doing to the letter D mathematically? Adding, subtracting, multiplying, or dividing? Abraham. So how will I move that 2A over? Divide later. We always do the division last. What about this VI squared? What's it doing mathematically to this expression here? Adding, subtracting, multiplying, or dividing? Adding. So how will I move it over? So Roy, if I hear you correctly, here's what I think you're saying. To get this by itself, leave that guy, minus this over to this side, and then divide by. So if I hear you correctly, you're saying it's going to be VF squared minus VI squared all over 2A. And I like the D to be on the left. I like what I'm trying to find to be by itself on the left. That's kind of a tradition. You okay with that? Okay, let's plug and chug. Here we go. V final, 0 squared minus V initial, 30 squared, all over 2 times negative 9.8. Now, I got to be a little bit careful. Take a look at what I've written. Maddie, how many numbers are there on the top of the fraction? Better put brackets around it on my good calculator because I haven't cheaped out. How many numbers are there in the bottom of the fraction? I better put brackets around it in my good calculator because I haven't cheaped out. If I'm going to type this in, it's going to look something like this. Bracket. By the way, I can do 0 squared in my head. What's 0 squared?
1.
By the way, I know you want to be funny. I don't want kids shouting out wrong answers on purpose because you might accidentally reinforce the wrong habit. Okay? Did you actually think 0 squared was 1? I hope you were trying to be funny.
I was trying to be...
Bracket 0 minus 30 squared divided by bracket 2 times. Now, I'm going to do this wrong. Remember I told you some of you might have missed the negative 9.8, Kelly, missed that the acceleration was negative. If you did miss that, you would have typed a 9.8, and here's what you would have got as an answer. What's weird about this answer? What stands out? What gets your attention? Stefan, it's negative, and you would have said, but wait a minute, which way is this car traveling? Which way is this car traveling? Forwards. Can't be. You would have said, you know what? I know the answer has to be positive because I've been in a car. And hopefully you would have been clever enough to go back and say, somewhere, some of my data, I'm missing a negative somewhere. And I am. Right there. Negative what? 45, I'm sorry, positive 45.9. Units. Meters. Okay? If you missed the units, I'm taking a half mark off. Or wrong units, I'm taking a half mark off. You know what? Just because we can, and I got room, I'm going to add a part B. I'm going to say, hey, how about find time? How long does it take them to come to a stop? I can figure that out. Let's see. I need an equation that has a t in it. And I'd like it to have a VF, a VI, and an A. It can have a D, but I'd like to try avoiding using the D, Jacob, because if I got the D wrong, then I'm getting the time wrong anyhow. Although if I have to, I will. Is there an equation that has T in it and then has these three? I got you, but let's let other people go for a second. Anybody see it? Okay, Van, you found it? You found it? Read it to me. Okay, stop. Ready? Let's see how good you are. Can you read it to me, getting the t by itself in your head already? So look at the equation. There's a VF on the left-hand side. Yes, sitting by itself there? Yeah. Okay, see where the t is on the right-hand side? Yeah. What are you going to do with that VI? Yep, and then what are you going to do with the A? So are you saying that? You're right. Now, if you can't do that yet, don't worry. But in a couple of weeks, almost all of you will. It's a great time saver. Trust me. I had a student a few years ago named Ashley. Ashley was a very strong student, straight A's. But she had got to this by memorizing everything. And so she tried to memorize every different variation of the equation. She got through, I never had her for Physics 11. She got through Physics 11 doing that. After 2 weeks of Physics 12, I broke her. She was, Mr. Dewick, I can't memorize all these equations. I know. It's going to be about 140. Or you can use your formula sheet, memorize the 5 most important ones, and I'll teach you how to rewrite them into the other 135 equations in your head. So if you're a little uncomfortable with this formula manipulation, Taylor, buy into it. Trust me. Trust me. You'll like this. Oh, let's plug in numbers. What's V final?
0.
Nice. I can do math with 0. Minus. What's V initial? 30 all over A. Negative 9.8. Is there more than one number on the top? Yep. Better put the top in brackets. What do you get? Now, if you have a calculator here and you aren't trying this right now, I got to be brutally honest with you. That's stupid. Because many of you don't know how to do your calculators very well at all. And I've already told you guys in Physics 12, one of the #1 errors I see on tests, I see all the right work, I see all the right numbers, and I see the wrong answer. What does that mean, Jordan? They didn't know how to use their calculator. This is your time to make those mistakes. What do you get? Positive, yes. 3 point what?
0, 6, 1, 2.
Stop. How many sig figs in my data? Look at my data. In the question, how many sig figs in my data? Cole, 3 in the first 30.0, 3 in the 9.80. So Cole, give me an answer to 3 sig figs. Don't be going on and on. What's the answer?
3.06.
Units. Yeah. Okay. If you didn't get that on your calculator, later on when I say get to work, call me. It's going to be a bracket error. I almost guarantee it. If you don't have a calculator here, later on I'm going to make fun of you. Example 5. A car travels at 15 meters per second and it speeds up uniformly. Cool. Over the next 5 seconds, it travels 85 meters. Find the acceleration. Okay. Greg, what do they ask me to find in this question, my friend? I'm going to write down A equals question mark. Hey, it's no longer blank. I feel better. Cliff, let's read through this together. I see a 15. See it, Cliff? What's the 15? And don't say velocity. What's the 15? Which velocity? Initial, okay. Right, if you guys say velocity now, I'm going to say, it doesn't tell me anything. Which one? Speeds up uniformly. That's me saying the acceleration is constant. Now, in Physics 11 and in Physics 12, the acceleration will always be constant. So I'm going to stop adding that phrase after a while because it's just a waste of me typing. What I'm going to say is if the acceleration isn't constant, I'll tell you and it will be very, very clear. But really, we'll need calculus to do it properly. And we only look at that in a bit of Physics 12. So I'm not going to always say, Aaron, acceleration is constant. It is going to be. Let's keep reading. Oh, Cliff, what's the 5? Darn right. What's the 85? Cliff, I'm looking for an equation. Do I have 3 things and finding a 4th? Yep. I'm looking for an equation that has A, V, I, T, and D in it, folks. Which one? Darn right. Okay. This is, out of the 4 equations, the most complicated one. Anybody in grade 12 here? Okay. This is a quadratic. Does that name ring a bell from last year? It's got a square. Okay. This is the equation where I don't try and rearrange it. And the reason it's tricky is how many t's are there on the right-hand side? 2. It's tricky to get the t's by itself because there's more than one. Now, I will rearrange it if one of the values is 0. Sometimes if vi is 0, then you get a much nicer equation. Sometimes if a is 0, you get a much nicer equation. So I won't be completely consistent. Sometimes I'll rearrange this, sometimes I won't. You guys will pick up when you can and when you can't. I mean, I could get the a by itself for what it's worth. To get the a by itself, it would be minus the VIT over, divide by t squared, times by 2, divide by, forget it. We're going to just plug in numbers now and then get the a by itself. Cliff, what's D?
85.
By the way, are we speeding up or slowing down? Are we expecting a positive or a negative answer? See, built-in error check. If you know. What's VI?
15.
What's T? 5 plus, and I usually write 0.5 at this stage because I'm going to go to my calculator and it's easier to type 0.5 on my calculator than a half. A T squared. Let's tidy this up a little bit. I get 85 equals 15,575? No, yes? Yep. Plus, oh, and you know what? I don't think I need a calculator for this next bit either. Enzo, what's 5 squared?
25.
What's half of 5 squared? Because there's a 0.5 in front. What's half of 25?
12.5.
I think it simplifies to 12.5a. There's my equation. This one's a little better. How would I get the a by itself? What am I going to do with that 12.5 on my last step? What's the 12.5 doing to the a mathematically? Multiplying. So how will I move it over later on? Divide. But there's also a 75. What's the 75 doing mathematically? So how will I move it over? So if I hear you guys right, you're saying a equals the 85 minus the 75, and then you would divide by the 12.5. I think you're right. 10 divided by 12.5? What do you get? Yep. 0.8. How many sig figs? At first I thought 2, and I was going to look at Cole, and I was going to say 0.80. Oh, wait a minute. No, I said look at the time. 5 seconds. How many sig figs is that? 5. So I'll go to 1 sig fig. 0. That is to 1 sig fig. And its acceleration, what are the units, Cole? Yeah. By the way, now that I have the acceleration, I could also find V final very easily. Let's do a fun one. Go back in your immature childhoods. Cast your mind back to when you're about 8 years old. Life was simpler. You were all shorter, most of you. So you're on a slide. A child slides down a playground slide, accelerating from rest and traveling 6 meters. This is a long slide. There's a slide in Stanley Park that's almost 6 meters long. It's almost the ladder is even a little higher than this ceiling. It's an old school slide back when they built playgrounds where kids could injure themselves on. Not the sucky playgrounds you guys had, right? You guys had the safe, sanitized ones. My playgrounds were great because I could kill myself on them if I wasn't careful. You know, we learned. In fact, we learned how to land properly. When you land, so the child travels 6 meters in 4.5 seconds and they hit the ground. What do they do when they hit the ground? They bend their knees to take the impact, hopefully without their ankle cracking. Now I'm getting old. And they bend their legs, how far? 20 centimeters. As the child stops. I'm noticing the word stops, that's going to be important later too. What is the child's acceleration in stopping? This is a tough question. This is your first two-parter. I think this question has 2 parts. You know how I know? I think there's on the slide and on the ground. See it? You read it? See it? So you know what I'm going to do? How many parts does this have, Stefan?
2.
I'm going to draw a line down the middle. And I'm going to go slide, ground. And I'm going to defic very, very carefully, but I'm already cluing in. Just the fact that I've drawn a line down the middle, I'm going to keep my eyes wide open, Roy. This is going to be a tougher question than normal, but I'm going to take the challenge. Oh! That's a key phrase. Underline that. That tells you something. Yes? That's one of the ones I told you to watch out for. What's that telling me? Which VI? Slide or ground? Then I see a 6. Doug, what's that? Slide or ground? Yeah. I see a 4.5, Doug. What's that? Time? Slide or ground? When they hit the ground, ooh, I bet you the rest of this is going to be in the ground section. Their legs bend 20 centimeters. Now, I got a bit of a problem. We don't do math with centimeters. 20 centimeters, how many meters? 0.2. So I'm going to write, oh, that's a distance as well. 0.2. And because I changed the units, I'm actually going to write the units next to this. You've noticed normally I don't. What I usually do is if I change the units, I'll write the new units just to let myself know when I'm looking later on, hey, where'd that 0.2 come from? Oh, yeah, I did a conversion. Stops. What's that? VF. What are they asking me to find? Slide or ground? Problem. Huge problem. Well, yeah, I told you guys you need 3 to find 4. I got 2 to find 3. Can't do it. But I do have 3 things here. That means I can find a 4th thing over here. So let's see if we can find something over here that might help us over here. I got VI, I got D, I got T. What else can I find over here that might make my life easier? VF? On the ground, you telling me that that's your speed at the end of the slide too? And this is a great question. This is the key to solving this. I'm glad Cliff asked this. Cliff, here's what I think. At the bottom of the slide, before you hit the ground, you're not stopped. That's your VF at the end of the slide. Oh, ooh. But you know what, Cliff? I think this VF is also going to be the same number as that VI, because the final speed at the bottom of the slide, isn't that your initial speed when you hit the ground? Yeah. Right? You follow that or no? If not, I don't mind saying it again. This is the key to solving this question. We need to realize that when you're going down the slide, you're speeding up, and just before you hit the ground, in fact, let's even say the split second you hit the ground, you've got a V final. That's what I want to find on the left-hand side, on the slide section. Oh! But that V final is going to be the initial velocity when I start to bend my legs. That's the trick to doing this question. That's why this is a two-step question. And it's also just nerdly cool because you've all been on a playground. Okay, so let's look on the left side. I got VI dt and VF. Is there an equation that has VI dt and VF in it? And I guess no A, please. There is one. Kelly, which one? Yep. Okay. So D equals, let me write it out. I'm going to say a half. Yeah, keep going. Close bracket. By the way, any of the stuff on this side, 0. Which one? Oh, so you're saying that I could actually in my mind go yoink? What's 0 plus VF? Just plain old VF. In fact, I would argue, Kelly, that I can rewrite this equation as a half VFT. Right, you're good? Yeah. Shut up. I mean, okay. What are we trying to find? Oh, let's get the VF by itself. What am I going to do with the T? Divide. What am I going to do with the 1? What's the 1 doing right now? Timesing. So what's the opposite of timesing by 1? Dividing by 1. Will dividing by 1 change my answer at all? So can I just from now on, and we'll all agree, we're going to ignore the 1s and skip the 1s, and can I not even bother mentioning them if that's okay, please? Oh, where is the 2 on the bottom? So that means it's dividing. So how will I move it over? So if I hear you correctly, it's divide by T times by 2 to, over on the D. If I hear you correctly, I think it's going to be this. Times the D by 2, yes? Divide by T. That's V final. Is that what you're saying? I would agree. It's going to be 2 times 6 divided by 4.5. 2 times 6 is 12 divided by 4.5. Oh, it's 24 over 9. It's going to be 12 over... No, it's going to be 8 over 3. 2.6666666. I could be... no? Yeah, ooh. Mr. Duke can do decimals in his head. I'm going to write 2.6667 meters per second. Mr. Duke, why'd you go to so many sig figs? Is this my final answer? Then I'm not rounding off unless I have to. In fact, what I'm going to do is I'm going to go 2 times 6 divided by 4.5. I'm going to keep that number stored on my calculator because that number is actually accurate to like 50 decimal places. And I'll use my answer button on my good more than $5 calculator that I finally purchased after Mr. Dewick ranted and raved and told me that it was useful. Let's go over here. So, Cliff, do you see why I can say this is the same number? Did Doug convince you? Yeah? Good. So now I'm looking for an equation that has d, VFA, and VI in it. Oh, and I guess not T. And by the way, I tried to make these numbers up. They're pretty reasonable. If you think about it, when you hit the bottom of a slide, if you're a little kid, you do bend 20 centimeters is what, about like that? You do bend about that much, give or take. Hey, what equation has d, VF, VI, and A in it? Yep, stop. Are you going to say something with squareds in it?
Yeah.
Okay, smarty pants. Let's see how good you are. Get the A by itself and read me the equation in one fell swoop, can you? It's advanced. Let's see. Visualize it. Yes, yes. See where the A is? See where the A is? See it, see it, see it, see it? Okay, what's in front of it being added on? So how would I move that V, first of all, VI squared, yes?
Yes.
How would I move the VI squared over? So there was already a VF squared there, yes? And you would minus the VI squared over to that side, I agree. And then how would I get the A by itself? That's the equation we're using. So we... Yeah, yeah. Yeah! See, it can be done. In fact, for many of you, it will be done in a few weeks. I would probably show more work on a test or a quiz, but taking shortcuts in my homework, I'm in. Oh, let's plug and chug. A equals VF 0 squared minus 2.6667 squared, all divided by 2 times 0.2. Enzo, how many numbers are on top of this fraction?
2.
Brackets. How many numbers in the bottom?
1 or 2.
Brackets. I'm gonna go like this. Enzo, what is 0 squared?
0.
So I'm going to ignore the squared on there, but I'm going to go minus, and I'm not going to type 2.66666667. If you have a crappy calculator, you might have to. I know where my answer button is. If you have your answer button, use that squared, because that's going to be way more accurate. Close bracket, divided by bracket 2 times 0.2. I heard someone say something very intelligent. I think it was Roy. Did you murmur, I got a negative?
No.
Oh, I thought I heard somebody murmur, I got a negative. Do you get a negative? What'd you get? What? Cole, he said, I got a negative, but Duick, that didn't surprise me. That confirmed that I'd done this right because he's slowing down. I know if you're slowing down, Duick, that's a negative acceleration. You get this, yes? Negative 17.77777777. Pardon me? Guarantee you didn't. You typed it in wrong. And I'll come look at how you typed in a second. Okay? I got negative 17.8 meters per second squared. Okay? Doug's got a fancy smancy graphing one. So we're back. Nice little question. What's your homework? First of all, finish 1, 2, 3, and 4 if you haven't. And I also have a sheet for you that just practices the defic part. So your homework, this sheet here, I called it using the constant acceleration equations. I've done the list the data for you. I haven't given you the word problems yet. All I've done is I've said VF equals something, VI equals something. All you're doing on this is practicing finding the formula faster, because that's where part of the slow thing is, finding the correct equation, and rewriting the equation if you want to try and do that step. The only equation that I don't rewrite usually is the D equals VIT plus a half AT squared, unless one of those is 0. The answers are on the back, sort of. What I did is I got all the answers and then I wrote them in a random order. So when you get an answer, if you look at the back, it should show up there somewhere. You can kind of cross it out as you go along, and you should end up with all of the answers crossed out. Okay? So you have the remainder of class to work on that quietly, and I have a video to show you. But I got to pause this. Stop.